In this presentation, we will examine Modbus over serial and Ethernet networks, understand the different wiring standards for Modbus serial communication, examine master-slave over serial and client-server over Ethernet connections, look at Modbus addressing. Modbus was originally a proprietary communication protocol designed in the late 1970s to communicate with Modicon PLCs. Nowadays, it's an open protocol or has open network architecture. This means that many device manufacturers can freely use the protocol to communicate with a wide variety of controllers called masters and devices called slaves. There are three main versions of Modbus, which are known as Modbus ASCII, Modbus RTU, and Modbus TCP IP. Modbus ASCII and Modbus RTU are serial communication standards which send a stream of bits in series over a serial cable in daisy chain configuration. The Modbus RTU standard network topology is a daisy chain with all nodes wired in series. It is not suitable for a star topology. Modbus TCP IP can use Ethernet cable and other networking components to send data in encapsulated frames over the network using various topologies. Modbus ASCII is the original version from the 1970s and is still used today. ASCII is a method of encoding data as a series of 256 characters. This encoding method uses twice as many bytes to transmit the same content as a Modbus RTU message, which uses binary encoding. In RTU, each 8-bit byte in a message contains two 4-bit hexadecimal characters, which effectively doubles the data throughput for the same baud rate. Modbus ASCII begins and ends messages with a series of characters, and Modbus RTU uses a more efficient time gap. ASCII also uses a less effective error checking method called LRC error checking, whereas RTU uses the more accurate CRC error check. The two modes are incompatible, so a device configured for ASCII cannot plug directly into an RTU network. Modbus RTU is far more popular due to its efficiency and flexibility. CRC stands for Cyclic Redundancy Check. It is 2 bytes added to the end of every Modbus message for error detection. Every byte in the message is used to calculate the CRC, also known as the checksum. The receiving device also calculates the CRC and compares it to the CRC from the sending device. If even one bit in the message is received incorrectly, the CRCs will be different and an error will result. As the Modbus protocol is just a messaging structure, it is completely independent of the physical layer, but Modbus RTU will traditionally use one of the 3 electrical standards: RS-232, RS-485, and RS-422. RS-232 is a point-to-point arrangement where the distance between the 2 devices is less than 15 meters. There can only be 2 devices on this type of network. Before your printer got an IP address, this was a common way to connect these 2 devices. To connect more than 2 devices on the same line, and if a distance is more than 15 meters in total, RS-485 or RS-422 should be used. RS-485 is the common standard used, as it can connect 32 different devices at a distance of up to 1200 meters. The data is sent as a series of 1s and 0s, called bits. Each bit is sent as a voltage. 0s are sent as positive voltages, and 1s as negative. The bits are sent very quickly, usually 9600 bits per second. The baud rate, or the number of bits per second, is usually set between 9600 and 19200, and all devices on a network must use the same baud rate. Modbus can be configured for a wide range of speeds to suit different applications, such as low speed for radio link or high speed for mission-critical process control. Usually termination is not required for baud rates of 19.2 baud or lower at distances of up to 1200 meters. A Modbus RTU serial network will have a master device, such as a DIN rail mounted card, which will issue commands to the slave devices. Slaves will be Modbus compliant and have the necessary technology on board to communicate. The slaves will not communicate with the master device unless they receive a command to do so from the master. The master can write data to the slaves as well as read data from them. A Modbus master could be a PLC SCADA system, and a slave could be a controller such as a PLC or a device such as a VFD, sensor or actuator. The Modbus master can also act as a slave if it is acquiring data from sensors in the field and passing it on to another Modbus master, such as a SCADA system. Each RTU network needs to have its own master device, and each slave device will need to have a unique address from 1 to 247. The address 0 is reserved for broadcast. When the master sends a request to read data, the first byte it sends is the slave address. This way, each slave knows after the first byte whether or not the message is for them. Even though RS485 standard will only support 32 devices in a single segment, if more devices are needed, a repeater can be added to extend the network. The Modbus RTU master message will begin with the address of the slave to receive the message. Next is the function number or command that will be performed. Then, the data that is required for the function to execute properly. Finally, the CRC value is added at the end. The request. The function code tells the slave what kind of action to perform. For example, function code 03 will request the slave to read holding registers and respond with their contents. The data field will contain the information telling the slave which register to start at and how many registers to read. The response. If the slave makes a normal response, the function code in the response is an echo of the function code in the request. The data section contains the data collected by the slave, such as register values or status. If an invalid request is transmitted, the function code is modified and a 1-byte error or exception code, which provides a reason why the request is faulty, is entered in the data field. Information is stored in the slave device in 4 different tables. 2 tables store on-off discrete values, coils, and 2 store numerical values, registers. The coils and registers have a read-only table and a read-write table. Each table has 9,999 values. Each coil is 1 bit or a bool and assigned a data address between 0000 and 9999. And each register is 1 word, 16 bits or an int, and also assigned a data address between 0000 and 9999. The coil register numbers can be thought of as location names, since they do not appear in the actual messages. The data addresses are used in the messages, and the coil or register to access is designated in the function code. Any single register will contain a 16-bit integer, and any 2 consecutive registers can be combined to give a 32-bit integer, or double integer. This 32-bit integer could also represent a floating point number, known as a real number. This is simply a number with a decimal point, followed by up to 7 digits. Example request frame. The master requests the contents of analog output holding registers 40108 to 40110 from slave device with address 17. 11. The slave address. 3. The function code 3. 006B. The data address of the first register requested. 0003. The number of registers requested. 7687. The CRC. Example response frame. 11. The slave address. 3. The function code 3. 6. the number of data bytes to follow. AE41, the contents of register 40108. 5652, the contents of register 40109. 4390, the contents of register 40110. 49AD, the CRC. The Modbus specification doesn't define exactly how the data is stored in the registers. Some manufacturers' equipment transmit the higher byte first, followed by the lower byte, and others transmit the lower byte first. Also, when registers are combined to represent 32-bit data types, some devices store the higher 16 bits in the first register and the remaining in the second, while others do the opposite. It doesn't matter which order the bytes or words are sent in, as long as the receiving device knows which way to expect it. Many Modbus gateways, or HMIs, have a word swap function to quickly resolve this issue. It is also possible to send Modbus RTU data across a network of Ethernet switches and cable. Modbus TCP uses the TCP and IP protocols to route Modbus data which is encapsulated in an IP packet. This is basically a Modbus RTU message transmitted in a TCP IP wrapper and sent over a network instead of serial lines. TCP must establish a connection before transferring data, since it is a connection-based protocol. The master, or client in Modbus TCP IP, establishes a connection with the slave, or server. The server waits for an incoming connection from the client. Once the connection is established, the server then responds to the queries from the client until the client closes the connection. In order for Modbus to communicate across the network, a new 7-byte header called the MBAP header, Modbus Application Header, is added to the start of the Modbus message. This header contains the following data. Transaction identifier, 2 bytes set by the client to uniquely identify each request. These bytes are echoed by the server, since its responses may not be received in the same order as the requests. Protocol identifier, 2 bytes set by the client. Length, 2 bytes identifying the number of bytes in the message to follow. Unit identifier, 1 byte set by the client and echoed by the server for identification of a remote slave connected on a serial line. The Modbus CRC section is dropped as the Ethernet checksum will now perform the error checking. If a response comes from a server device directly connected to the TCP IP network, the transaction ID is sufficient to identify the remote server, therefore the unit ID in the MBAP header is not used. If the remote server is connected on a serial line subnetwork and the response comes from a router or gateway, then the unit ID identifies the server. A Modbus map or register map may be supplied with your Modbus enabled device. This map is simply a list for a slave device that defines what the data is, e.g. pressure or temperature, where the data is stored, e.g. which tables and data addresses, how the data is stored, e.g. data types, byte and word ordering. Some devices come with a fixed map defined by the manufacturer, and other devices allow the operator to configure or program a custom map to suit their needs. Modbus ASCII and RTU are the original versions of Modbus. Modbus RTU is by far the more popular as it is more efficient and flexible. Modbus RTU uses RS-232 and RS-422 or 485 electrical standard at the physical layer. This allows up to 32 devices on one network. As many networks are possible as there are slots available for each master. The baud rate is the number of bits per second and is usually set at 9600 baud, but can be adjusted to suit the application. A Modbus RTU master can be also configured as a slave in order to send data to another controller or PLC SCADA system. Each device has 4 different tables for storing information, 2 coils and 2 registers. Each coil or register has 9,999 values. The function code identifies the coil or register to access, and the value for that specified coil or register is given in the data field. Exception codes identify a fault or failure on the network and are returned in the data field. Any two consecutive registers can combine to give a 32-bit integer or a real number. Modbus TCP IP uses Ethernet networks to transmit Modbus RTU frames across a network of various topologies. Modbus TCP IP uses an MBAP, Modbus Application Protocol, header to encapsulate the Modbus RTU frame. This is then encapsulated in an Ethernet frame and sent over the network. A Modbus register map is a list that describes what the data is, where it is, and how it is stored.